Alright, so I'm just here going through question 4 of exercise 9H, which is this one. The maximum point on the curve with equation y equals x root sine x, where x is between 0 and pi, is the point A. Show that the x-coordinate of point A satisfies the equation 2 tan x plus x equals 0. So this is an exam question. You can tell by that bit. Alright, so I'll copy down the key information here. I've got y equals x root sine x. There's my domain. And A is a maximum point, so I've just done a little diagram there. And I've got to show that the x-coordinate satisfies this. Well, I know that to find a maximum point, the derivative would equal 0. So if 2 tan of x plus x equals 0, I think I basically need to show that the derivative of this is 2 tan x plus x. So I start by rewriting it. Here we've got a product. One thing times another thing. So my first thing is x. My second thing is sine x to the power of minus 1. Sorry, not minus 1. Power of a half. Getting confused there. So square root means a half. So it's easy to differentiate x. Differentiating this is a bit harder because it's actually a composite function. Now I know that the derivative of sine x is cos x, and I kind of treat this bit as if it's a polynomial. So I'd multiply down by a half and reduce the power by 1. So this is probably the trickiest part of this question. It's actually differentiating sine x to the power of a half. Now, I'm just going to go over that in a bit more detail here. If you're happy with that, I guess just fast forward this next bit. So I'm going to be differentiating sine x to the power of a half, but I'm going to properly now use the chain rule because this is a composite function. Okay, so I'm going to be using u and v again, but it's not the same u and v as over here. I'm kind of starting again. So if I rewrite this and I say y is u to the power of a half and u is sine x, then dy by du is a half u to the minus half, and du by dx is cos x, and dy by dx, and this is the chain rule now, is dy by du times du by dx, which is half u to the power of minus a half times cos x, which is half u is sine x, so it's sine x to the power of a half times cos x. Right, I'm glad I did that out in full because I realised I made a mistake here, so actually this is wrong, and doing it fully I get half sine x to the power of a half times cos x. Right, so that was worthwhile doing that properly. Okay, now I'm going to use the product rule. So over here, dy by dx is, so product rule says y dashed is u dashed v plus uv dashed. So u dashed is 1, v is sine x to the power of half, then u is x, and v dashed is half sine x to the power of a half times cos x. Let's put some brackets around that. Okay, let's try and simplify this down a bit. So let's take the sine x to the power of a half out the front, and then I've got 1 plus half cos x. Okay, for this to be for a maximum point or for a stationary point, this thing here has to equal 0. So I'm going to turn over now and go, we're basically going to try and get this somehow to look like this. So I get sine x to the power of a half 1 plus half cos of x equals 0. Alright, so either sine x to the power half, or root, has to be 0, which means sine of x has to be 0. And let's look back at our domain. X is between 0 and pi, strictly between 0 and pi. So let's think about our sine curve. Sine starts here, goes down like that. There's 0, there's pi. And x is strictly between 0 and pi. Now sine x equals 0 only when x equals 0 or pi within that domain. So this gives us no solutions. It's worth noting that if this had said, if we'd had this, we would have had two solutions here. We'd have had x could be 0 or pi, but we don't have that. So our other solution has to come from this side. So I've got 1 plus a half. Hang on, I think I've made a mistake here. I have. This should be a minus half, which means this should be a minus half, which means there should be a sine x here. Half sine x cos x. Because sine of, I need, a whole, oh no, minus 1. To balance that out, if I take that half out the front, multiply by that would give me a minus half. Okay, so I've got cos x over sine x. 1 plus half cos x over sine x equals 0. So I've got in the back of my mind this fact. Okay, this fact is in the back of my mind. This identity. So I really want it to be sine x over cos x. That would be ideal. So what I'll do is take minus 1 over there, and then I'll kind of flip it, I suppose. So taking the reciprocal of both sides. That's allowed. So taking the reciprocal of both sides, I'm basically just flipping my fraction, okay, or doing 1 over. So this side becomes 2 sine x over cos x, and minus 1 over 1 is still minus 1. So that is 2 tan of x. Have I also missed out an x somewhere? Yes, I have. Right, second mistake, there's an x there. So there's an x there, so there's an x there. So there's an x there, and there's an x there. Equals negative 1. 2 tan x plus x equals 0. 2x tan x equals minus 1. It doesn't actually look the same. Yes, I know why, because this x would be at the top, which means this x would be at the bottom. So before so I get 2 tan x over x equals negative 1. So I get 2 tan x equals negative x, which means 2 tan x plus x equals 0. Okay, so I'm there, even though I made a few mistakes along the way, but we found them. So I hope you followed that. And really what we can say is that the stationary points are when this is true, and if there's a maximum is a stationary point, therefore this is true. So we would say true for stationary points, all stationary points on this curve, therefore true for x value of a, which we've been told is a maximum point. There we go. Okay, you might want to kind of recap that a little bit, rewind, see if you can figure it out. Sorry about all the mistakes, but we got there in the end.